Hello, my name is Robin Mitchell, and today in this podcast for Electropages, I am joined by Travis Neuman and someone new who I've not seen before. Do you want to introduce yourself?
I'm Scott Fitzharris.
He's one of the engineers in special projects.
This is the special projects for Omnetics, correct?
Correct. Mm-hmm.
Fantastic. Now, I would like to say to the audience very, very quickly that Travis is one of my favorite guests, as we've had many funny conversations in the past and exchanged a few memes. The idea for this podcast is we're going to be talking about nano connectors, I believe. So I think the best place to start is just to give us an idea of what nano connectors are and where we typically see them.
All right. So this is Travis. If we're just on podcast for the sake of audio, nano connectors are a series of connectors, and it's really dictated by the size or the pitch of the contacts and the current rating. So Omnetics manufactures primarily micro and nano, nano being on a 25 thousandths pitch or 1.27 millimeters. Max current generally is 1 amp, although really end uses are used a lot in like digital electronics and those sort of things. So the likelihood of you needing that much power is fairly low. We've got a lot of customers that use them in like satellites, communications, vehicles. We've even got some flavors for dismounted soldiers in a circular connector, those sort of things. So there's a lot of different uses. It really comes down to needing a small form factor and getting those signals through. And there's a lot of specialization that exists within nanos too, really driven by specific applications. So you see them just across the board.
And so let's talk about the characteristics of these connectors, because you said that the nano ranges about the 1.27 millimeters. Is that correct?
Correct, and that's pin-to-pin spacing. Absolutely.
That's pretty small. 1.2.
Yes,
I mean, yeah, that's really small.
When it comes to manufacturing, we have about 400 employees here, and out in the floor we have easily 300 microscopes. So it is absolutely small. No doubt about it. Absolutely.
So, and you're saying that these things have current capabilities of about an amp as well?
Mm-hmm. Yes. One thing that does happen, though, like I had mentioned space use, like CubeSat, SmallSat, that sort of thing, people do derate them as well, just so there's
of course,
an additional safety factor inside of that. For solutions requiring more power, what we'll see regularly here at Omnetics or in special projects, even for samples, will be options of using multiple contacts for delivering the needed current, or we'll see hybrids too. Yep. That's pretty common, and what that means is they'll use a larger contact so they have more cross section to deliver that power needed. So you're in the realm of custom connectors there. So
when you say hybrid, so let's talk about the nano connector. So you've got a 1.27 millimeter pitch, and you're saying they go up to about an amp. And then you mentioned about hybrid. Are you saying that how exactly has a customer changed that kind of connector to for their application in that case?
If you want this one, I can go after it too.
Yeah. Well, Scott here.
We should do rock paper scissors for each question.
Yeah.
Sure. And then, so typically when you're talking a hybrid, it's driven by a customer requirement with a size and a power constraint. So then we could typically take what would normally be a normal width connector, remove a few of the pins and replace it with, let's say, one power pin, so we can get the proper spacing for that one pin, or 2 pins if needed, to carry your power, and then the rest of the connector is still the small nano form factor. So basically we end up kind of making a custom connector inside a package that they can utilize that's smaller than going to a micro connector across the board for their solution, but can give them the power capability of like a micro contact at 3 amps per se.
Oh, that makes sense. So you might have, let's say, just as a poor example, let's say like a DB9 connector, and you've got your 9 pins, and then you might say, well, let's take the 3 pins off the left here and replace it with one really big pin, but the other ones still have that small form factor.
Absolutely.
So you're mixing 2 different types into the same package.
Yeah, or another idea, since we're kind of in that realm right now, right? So let's say we have a camera, and it has a microphone and everything else in it, and maybe you have a light as well, because Robin, you're making your TikTok videos, right? So
obviously,
you got to do what you got to do. So then you can use the 2 larger contacts in that small package to deliver the power to your camera and your big ring light. And then all of the smaller pins and sockets will take care of your audio, your video signals going to whatever device it needs to be plugged into.
And by using this hybrid cable,
it's just all in the essence of saving as much space or weight, depending on the application again for the customer.
And it also reduces the complexity in terms of the cable setup, because you've only got 1 cable as opposed to 3 or 4 different cables, one for data, power, and other things.
Correct. Yep, absolutely correct. I mean, we've got, I'll say one thing that just, we've got a request that shows up is it's very common that customers will want some sort of special configuration as well. I need, for instance, one that is in discussion. I need 8 twisted pairs, so that would be like your data lines generally. 2 larger 22 gauge power lines, and then several just discrete wires. And initially, we'll put that just in a bundle. We'll just use the discrete components, and then eventually, provided the design works out, we'll get a custom cable made as well for them. So it really just comes down to what are you working on.
Interesting. And so let's move the conversation on a little bit to Omnetics as a company in general, because I don't think we've had any podcasts with you guys yet. We've only done the Ask the Expert articles.
Right.
And so one thing that we've always laughed about a bit is the fact that you handle pretty much any environment that man has ever encountered, in terms of like the operating environment that the cable or a connector might need to be in. So I think, so if I remember correctly, we joked about like from heaven to hell kind of thing, right to the edge of space, right down to the center of a volcano. Unfortunately, unfortunately for the staff who have to go and test those samples.
Yeah, no, I stole the heaven to hell thing from somebody in sales and marketing.
Brilliant.
And that's absolutely it. It's all about high reliability at Omnetics.
Yeah.
Heaven to hell's the joke, right? So which that means space, aerospace, military, medical, oil and gas. It's all high reliability, very much custom solution provider for people. I mean, we have off-the-shelf component connectors as well. That's not an issue in the micro and nano realm. And then, I was going to go somewhere, but I guess I did. I'm not going to. So yeah, we have quite a bit. I mean, we've been in business for since '68 in some fashion, 1968. So quite a number of years. It actually started as a plating company, and then we transitioned to connectors long before myself or Scott ever came on board. And I've really been doing that since I think it was somewhere in the early 80s. So something like that, 83 or somewhere like that. Yeah, been quite a while as a connector company.
And I think I remember this conversation before. I think weren't we saying that the reason why Omnetics may have been able to transition into connectors was the fact that because of the plating capabilities, you knew how to plate small parts, which is a critical component of modern connectors.
Absolutely. I mean, they were doing my understanding, they were doing a lot of business with Cray, a number of years ago, and having the plating portion, doing all of this work that's right in the realm of connectivity, it just made sense to take on that additional responsibility or workload. And ultimately, that's where the company decided, yeah, this is our direction. This is where we want to be. And we've been doing small connectors for a long time. So which is really nice when you consider, like you had mentioned DB9 just a couple minutes ago, how everything's been miniaturizing for quite, just continually since really the beginning of the Omnetics in the 80s doing connectors. So
It's huge now.
DB9 is huge, exactly. Mm-hmm.
It is a very big connector, but it's a high reliability connector as well.
For us it is, absolutely. For us it is.
And
right.
so the reason why I brought DB9 up was because I think we talked about this in the past, where you might have a customer who needs a DB9 connector, but they need to add additional features into that connector housing. And what you guys can do is, with your special projects division, you can go ahead and basically create that for the customer.
Go ahead.
Yeah, I mean, with our capabilities, whether it's a prototype or a custom part, we can either, if it's a part they need for production, we can custom machine an insulator, or we can even 3D print it if we just need to make a sample. And then we can machine a housing on site out of aluminum, and we can make us either plate it or just use a non-plated aluminum or stainless steel part for a sample for testing, validation. Does it work? Is it what they want? And we can also, like I said, machine up production ready small quantity parts.
Yeah, the other thing is, with that in mind, so we're focused on micro and nano, but let's say you come and you want a DB9 in a harness, you want a banana jack plugged into a connector somehow. That's not an issue either. Omnetics, we do that type of work all day, every day. So if you want to,
the key focus of that is that it's the customization. That's the key factor of what when the client needs something customized, that's when Omnetics steps up.
Absolutely. There may be a box that, some particular customer, they may be purchasing an off-the-shelf box from some embedded system, let's say, and that has a specific vendor's connectors on it. Maybe we don't make those. It's not an issue for us to source those and integrate them into a solution for the end user. We do that all the time. And that's one thing in my mind, that's one thing that does differentiate Omnetics, is there's a number of other companies that wouldn't necessarily entertain that type of solution. So,
and so Omnetics is really the company that's going for what you would probably agree is some of the harder or the more difficult applications or scenarios where customers are in a really sort of unique situation.
Yeah, we definitely take on those. And we're a good solution provider for those type of customers.
Right, and one of the other things too, we have individuals as right now today that are going through, basically a recertification for the IPC 620, which is wire harness assembly. We've brought in space addendum training to Omnetics as well, again to address the quality and complexity needs that customers are asking us about. So we've got a fair amount of staff. I want to say it's 10% or more now, because we started about a year ago down that path with the for just based on the requests we've been getting from customers and where the market's headed. So.
Now, I've got a question that I think the audience would love to know about, and that's the Special Projects Division, which sounds a bit like a black project. So how about, it does sound a little bit kind of, it's like I don't know, like it's like the Area 51 version of Omnetics. So what actually is the Special Projects Group, and how does it help customers?
We support Omnetics in generally the individuals coming to us for development type work, sales. There might be a napkin sketch, if you would, or there's been some back and forth through the engineering groups of ourself and some other company, let's say, and they have an idea of what they'd like to do. So we do prototyping, as Scott mentioned, printing, machining, it could be whatever.
Yeah.
I mean, we have some prototypes that are coming now. We're doing 2 different types of printed shell. We're going to put some hardware on them, wire them up, that sort of thing. We support engineering. We've got a number of projects or connector series that we've been working to develop. So they may come in and say, you know what, we got this idea. We want to build a few so we can test them. Can you guys help us out with that? Absolutely. We support manufacturing as well. We've got there's a project that Scott was working on or is working on where they need a specific forming of the leads to go down into their circuit board. And Scott has a fair amount of experience based on what he's done for developing form tooling and that sort of thing. So it's all about just helping get things and getting things to the customer faster too. Grant's not in here today. He's actually in 620 training, and he really takes care of that portion of the requests also, the special projects, if you will.
Did I hear you mention something about form tooling? Was that the correct phrase?
Form tooling, yeah. For a lot of like the circuit board mount connectors, they have leads that they'll maybe want bent in a certain way, whether it's for through hole or surface mount. And yeah, we have to develop a tool or some type of process to bend those leads repeatedly.
And so you're not just what's the word? It sounds like you do your own research and development as well when it comes to manufacturing and design.
Yeah, for the most part, we figure out how to form it, and we develop the tooling in-house. And we support manufacturing and our manufacturing group when they need some help.
And I suppose then when customers come to Omnetics, you're not just got the experience of as a custom cable connector manufacturer. You've also got the experience of the fact that you know how to research individual customers' unusual requests, and so you can figure out ways to solve it.
That is correct.
Right, and you know the interesting thing is you see things in magazines and that sort of thing, and for us back here, we share magazines and things. Well, you see those ads, and maybe today there's a mixing system or a robot or something of that nature, or even a material. I've got a number of those that I've cut out, where you don't necessarily have a need for it today. It's kind of a cool type of kitschy item. And then at some point, there's a discussion and people are like, I need to shield this, or I need something above and beyond for vibration dampening or whatever. What do we have? Oh, well, there's this company that makes a filler material that maybe it looks like Jell-O, but you pot it in after the fact and it's great for shock and vibe, or these guys make a specific dispensing equipment, that sort of thing. So there's all sorts of black box type things that happen as well.
So is the so if a customer comes to Omnetics for a custom connector or cable, would all of those requests go to the special projects division?
No, the process really starts with the internal sales people. So so we use sales reps at Omnetics, and then those individuals will start the discussion. From there, if they get to the point where they want to make something, then the salespeople will generate a request, which will go to engineering. And then they can work engineer to engineer, tag in the salespeople on the emails, that sort of thing. And then they can hash out kind of the nitty gritty, right? Oh, I need this thing to work down in the volcano, let's say, or I need to send this thing to orbit around the sun, or maybe it's going somewhere super cold, you name it. They can work out those details. And once they get kind of a rough concept, we'll have some CAD put together, that sort of thing. Then we'll get it after that fact. And it may not be completely fleshed out. That's okay, right? We don't know that we can fit 21 wires in a back shell this size, or we need a certain level of shielding, or it needs to one of the other ones that's going on is it needs to be able to handle a certain voltage at altitude, that sort of thing. But then we can build that up, and we can do some testing and give the feedback and kind of refine that design in short order.
And so, if I understand it correctly, if a customer's custom connector isn't what's the word, kind of too complex, or it doesn't require lots of research and development around it, that might go to some other department who can whip that up really quickly. But if they've got a really unusual situation which needs a lot of extra attention, that's when you guys, the A team, come in and just kind of like do your thing.
Yeah, that's a fair assessment. If it's an iteration on something that we've done, many times before, we generally don't see it. And if it's something that's fairly in depth, then we will get it on many times, and that way we can also help in manufacturing in terms of making sure the bill of materials is what it needs to be, because a lot of times on these first builds we might end up making some edits. We generate a process for it, and as Scott said, we may even generate fixtures and those sort of things for manufacturing.
Correct.
Yeah.
I can sort of imagine I can imagine a situation where like it reminds me of one of those those like in the army when you've got the really like a special service mission, and they've got you guys on a line in the office. It's like we've got a mission here, boys. We've got to get this thing working in this condition, and we don't know how we're going to do it. It's up to you guys, and it's like, right, okay, got to figure it out. And the reason why I also say that, because when we talk about the huge different, well, the wide range of environments that you have to deal with, we talked a lot about testing in the past as well. So how do you want to go into a bit of depth about the different tests that you can do and how you develop tests for new environments that you haven't encountered in the past?
I can do it. You want this one?
You can do it.
So we have, so just testing. We have a number of pieces of equipment in our test lab and within QA. Really, I'd say they're the more common, salt spray, temperature resistance type testing. We have like as I mentioned just a minute ago, we have a small altitude chamber where one of the things that you'll get or see regularly is voltage will need to be derated, that sort of thing. We can do that in-house. DWB, IR testing, all sorts of things like that. We also have for like high-speed signaling, we've got that network analyzer and those sort of things too, for even testing incoming cable to make sure that we don't have skew issues and things of that nature as well. And then when it gets to certain things like shock and vibe is very common in this market. We don't have a shock and vibe table in-house. There's been some discussion about it. So if we have tests that are called, let's say I'll just say above and beyond for the sake of discussion, we will send those out to a third-party test house. And the nice thing about that too, as everybody knows, then you have, it's not just us saying our stuff is good or bad for that matter, but it's not us saying it's good. You have a third party that's saying, yep, okay, these meet this test criteria, that sort of thing. So
well, I suppose that is the purpose of a test house as well. So you can't expect to have every single test under one roof, because there's so many different things you could do.
Right.
So it also sounds like you're implying that when it comes to volcano testing, you'll find some poor sod in another company. You're like, right, it's your job, it's not Omnetics' job, it's your job to go into that volcano and get some samples out there, watching this poor guy trying to get some stuff out.
Send them to you next time, Rob, and that's how that's going to go.
Oh, God. But yeah, it's interesting, isn't it? Because like when you have a customer who comes up to you and goes, well, I'm planning to send something into space, and then you go, okay, where about in space? Well, maybe high orbit, or a deep space, and then you get all these different things you've got to consider. It really must be an absolute headache for you guys when you're trying to make connectors for really awful environments.
I mean, I think the biggest thing, like, you've got a lot of experience with shielding, Scott.
Yeah.
So, for instance, on that idea, it's like, to me, like, just the questions that can come with shielding, right?
Yeah.
So, like, what would be just the headache portion?
Well, part of the headache portion typically comes down to balancing the weight versus protection, versus the amount of coverage you need and the amount of emissivity you've got to deal with, and if you're up in space, there's a lot of radiation and stuff you've got to reflect out or keep out, but you also have a weight and size constriction. So sometimes you got to look at copper or even aramid materials to help. So that's more of the challenge, just trying to dive into what can they live with, what do they need, and then what material can we offer that kind of gets us in that window of, you want this, and we can get really close, or we can actually nail it. And then that's more the hard part. But outside of that, it's, at the end of the day, it's just building a connector. It's really more about the upfront understanding where it goes.
Yeah.
And what do we got to do specially for that specific task.
And so it sounds like what you're saying is it's not so much the connector itself and its manufacturing and design, but the way that, how do you negotiate with a customer to say, well, if this is going to be the environment you need to operate in, you need to understand that there are going to be these factors that your entire systems will be exposed to. We can't shield it entirely from radiation, because if we make it we could put a foot of lead around the thing, but that's not entirely practical. So we have to make the shielding thinner, so it conforms to your weight characteristics. But by doing that, you have to make sure that your system has some kind of anti-radiation protection, whether it's something like, I don't know, strong ESD protection if it causes a voltage spike or something, or if it, I don't know, flips a bit in memory. So it sounds like that the headache is actually the negotiation, or not negotiation, but more like making the customer realize that what they want may not be possible.
Yeah, and you might start off, it's like a lot of things. You start off with something in mind, right? And we'll just continue on this radiation theme. And maybe, let's say it's a surface mount connector, because there's one in my head I'm thinking of right now. So then they're like, oh, we need shielding. Okay.
Yeah.
Well, one of the great ways of doing that is using a denser material. So how about stainless steel? Well, this is a CubeSat application. We don't want to we don't need the mass adder. Great. Okay, got that. So then now we're back to aluminum, but guess what? We're looking at gold plating or something like that on the surface with a better conductivity that's going to be able to really help with the shielding portion of it versus just the traditional nickel plating. So, and then the customer
comes back to you and says, "Oh, but I don't want gold plating."
Well, again, and that's and that happens. That's fair. It really comes down to, okay, I understand that. Here's what the requirements are. So now we're looking at, let's say, for instance, now we're looking at, this is going to be gold plated, or do you want to do stainless, or is there some other option? To your point, do you want to put a lead wrap on the box or something of that nature, right? It's all trade-offs.
And so Omnetics ends up taking, sort of has to, we start the question again. Would it be fair to then say that Omnetics kind of works with the client to help them with their project, even though even though you guys just you design and manufacture the custom connectors, but you actually get involved with the project to give them guidance in what they might expect and things that they need to watch out for?
Absolutely. I mean, the engineering staff upstairs has worked on so many different projects which is great, right? So then they can draw from that experience, and they can draw from working with those engineers at other companies, and say, you know what, we tried something similar like this over here, and it worked out. Are you open to looking at doing that idea here? And more often than not, it's absolutely. So they might start with something in mind, and you may end up with something different to get to your solution.
And that's a really interesting point, because one thing I've always found is there's a bit of a funny phrase my wife always tells me, and if I remember the phrase correctly, it kind of goes, I think the phrase is, if you buy expensive, you only cry once. And the reason why I say that is because there might be engineers out there who look at like Omnetics as a custom connector solution service, and they might go, well, is there a cheaper way we can do this? Can we develop the connector ourselves? And then you think, okay, yeah, it might be cheaper when you've developed your first connector, but here's the problem. You don't know if it's going to work. You haven't got the experience in the years that Omnetics might have. You haven't got, and then you might find that the connector ends up failing, which would most likely happen because the person who's designed it isn't a connector, an expert like Omnetics. And so what Omnetics is providing the customer, it's not just the connector, it's the experience, the years, and the knowledge that come with that connector.
Right. Right. Yeah, and one of the things I think of too is the shock and vibe, right? You can get away using a surface mount connector. You can get away with that. Maybe you stake it with epoxy, you put some screws on it, that sort of thing. the people that are real serious about it are going to know, again, because of the experience, that through pull generally is going to give me a better result, right? Because now I have more support through the whole entirety of the board versus touch. And there's little nuanced things like that too that, again, unless you've had experience with, you may or may not know. So yeah, absolutely, absolutely. And I made a joke. So this is kind of one of my things. I worked at hybrid microelectronics company some number of years ago, and it was all whatever the customers brought in, right? Contract manufacturing, and I had made the joke. You can work in a company and maybe you work on this specific product line, and you understand this really well, right? So you've got years worth of experience working on this, and when you get into this type of business where you work on all of these other different projects, you could equate it to essentially call it dog years, right? Because now you've got all of these experiences that you get in the same amount of time, because you don't just see one specific set of challenges or problems. You see it from a wide variety, and it really just helps with problem solving when the next one comes in the door.
And it also gives you the opportunity to like you said before, when someone comes in with one problem, you might have seen another project where they had a similar issue, but hang on, this is going to get quite confusing now. Hang on, start that one again. So someone might come with you with a problem, and then you recognize that there could be another problem related to that problem because you've worked on another project before.
Absolutely.
And so it all comes together, and you go, well, I can give you a great example. And again, we talked about this last time, and it's when we said you might have a connector made of a plastic or some kind of material, and you think, well, it's rated for shock and vibration, so I can put it in a plane or in a high altitude plane. And you go, well, maybe not, because you get outgassing, and outgassing might only be something that only those who deal with very high altitude things will ever spot. So someone on a low altitude may not see it. Try and put that maybe another 10,000 or 20,000 feet in the air, and suddenly it becomes an issue. And an Omnetics engineer might go, I've seen that before, so you may want to keep an eye on that. And so the customer goes, oh crap, you might have just saved my whole design, because it's not just the connector that you've warned me about, but the problems that the connector is going to face will also be faced by the rest of my design.
Right, and one of the other lines is, an expert's just somebody that's had all the problems.
Pretty much. They've had all the issues before, so don't make the same mistakes.
Right, exactly. Okay.
Now the so let's go back to the nano connectors, because half this conversation has been nothing to do with nano connectors, which was why we're supposed to be here.
That's how it goes, right?
I know, it's ridiculous. So we talked about the industries, and then you're saying it's pretty much anything, computing, power, because customers can sort of like configure in their own way. But what would you say are the biggest challenges that customers face when they use these nano-sized connectors? And just to remind the audience, when we talk about nano, because these things are relative terms, nano is around the 1.27 millimeter pin pitch.
Yeah. Well, I mean, I guess when we're talking nanos, typically I see them used a lot for any sort of small application doing digital signal for one, or any small weight saving device in a satellite or UAV, or, I mean, they're used almost anywhere you've got a small package that can provide data and low voltage power, and they're a great way to shrink a form factor down when you don't have any high voltage requirements, or you only have maybe one or two high voltage requirements. So you can take your DB9 or your micro Ds, and you can shrink them all down, and now you can make maybe a 3-inch box, a 1-inch box. You can shrink your whole form factor down, one, to save weight, to save design, just to make it more sleek. People like things small, reduce the weight. Those are kind of some of the big keys, but it's also just, it can be a robust connector as well. It handles shock and vibe. It's military rated, and it's a great type of solution for any sort of package you can get it into. I guess.
Yeah, one of the challenges, this is the one that Scott actually worked on. One of the challenges you have is, now these guys are really small, And for instance, you may have a surface mount connector that's going to be plugged into, because it's hanging off the side of the board, right? It's a right angle. And one of the issues you have is when you plug into them, because they are small, they want to tip up, right? It's surface mount.
Yeah.
So then you end up with what's the solution? Well, one of the solutions is I put mounting screws on it. Okay, that's great. Maybe you can, maybe you can't. One of the other solutions that customers will do is they might end up having to use epoxy to stake this guy down because they don't have room for screws. This is very common. Oil field, especially satellites, that CubeSat, that sort of thing. They don't have room for it. So like one of the other things that Scott actually developed this was we sacrifice one of those fine pitch locations inside the connector, and we use a through hole pin. So now this whole connector is still soldered, but you've eliminated it wanting to tip up, because now you have a soldered point towards the front of that guy that helps to prevent that.
Which anchors it down.
Yep.
Yeah.
Right. So that's one of them. The other one of the other issues that we don't see in here, right? But I have several of my neighbors are engineers that pick a big defense company. I don't know, maybe we all moved into the same neighborhood for whatever reason. One of the issues I
smell a conspiracy. Carry on.
One of the issues they have is the traditional hardware. You've got screws, they're fairly securely mounted in there. So when you go to connect the pins and socket, connect the connectors together, what you really need to do is you need to slowly bring them in. You got to, left, right, just.
Oh yeah, snake them in. Yeah.
Yep, snake them in, walk them in.
Yeah.
And it's not uncommon once you get to like, oh, we're going to build a bunch of these. The people doing the assembly might go all in on one, all in on the other side, and it'll work. What you'll end up seeing eventually in shock and vibe is it's damaged it enough that it'll back out and you'll get discontinuities. So that's one of the challenges. Well, we have a solution where we have latching connectors, right? Mm-hmm. The other thing is you're building something inside of an airplane wing. You can't necessarily reach in there with a tool to be able to tighten that guy down. You need things to blind mate. Well, that's where latching connectors come into, right? So you've got that. Or some of the other things we've been doing challenge-wise is shielding, integrated back shells.
Yes.
Yep. So we're not on some connectors, we don't use separate pieces for a back shell to tie the shielding and everything to. We'll machine that all as one piece, right? Because one of the other challenges, and I saw an email on it this morning, is this is not an Omnetics thing, right? So, but the back shell actually loosened up during their shock and vibe testing, and this particular alert came out on email. So you integrate that, you don't have to worry about anything backing out. Now that's just going to do you better long term. So there's a number of different challenges that exist, and within the nano connectors. But latches are a big one for solutions. Again, we've got soldered down through hole type pins to eliminate some of the hardware or staking needs. And then some of the other challenges, that comes into the high-speed stuff with the terminations and whatnot. Yeah. Scott's far more versed in that than I. So, yeah, just for a few, just to name a few.
Just to make sure I understand this correctly, the back shell, are you saying that you've got like some kind of plastic body and the metal shell sits kind of like on top of it as a separate piece? Is that what the back shell is, or how would you describe it?
A lot of times our connector is a thermoplastic type body that's in a metal housing for the connector to connect to. And then a lot of times people would add a metal back shell that would use some sort of hardware to attach it. So what we're doing now is when we machine the metal body, we're machining it with the back shell built into it.
Oh, I see. So it's a singular piece.
Yeah, and that helps, like you said, one, you can't have it separate or back out. Two, you don't have any worry about like if you're just getting some sliding vibration, so that means you're not getting the right shielding transfer, because shielding isn't just about electrical transfer. It's, you know, it's got all the surfaces, transfer impedance, all this stuff. So when you're creating resistance, you can actually affect how your shielding works.
Now, just a quick question about the nano connectors themselves. We've established that like the Nano itself is the 1.27 millimeter pin pitch, but is it specifically like, is it pin and socket, or could it be anything? So like those flex cables, for example, or it could be anything in terms of like the way that it connects, or is it very, very specific?
Well, the connector itself is pin and sockets, but we can terminate it to a flex circuit, a cable, a circuit board.
Yeah, and we have a number of tail types.
Yeah.
We've got our Omnetics names for them. The reality is it's surface mount, through hole, card edge, to certain thicknesses on the card edge. Obviously, when you're looking at nanos, and you have 2 rows of pins and sockets staggered, there's not a lot of clearance there when everything's on 25 or 25.
Oh, it's 2 row.
We can be.
They can be.
It's 2. Oh, blimey.
Absolutely.
Yeah.
And so that means you've got 2 lots of legs coming out.
Correct.
Can't quite do it on camera like this kind of thing.
Yeah, your hands won't bend all the way, but you got the idea.
and so what's the pitch between? Is it also 1.27, like the whole 90 degrees?
To think about it, you would draw equilateral triangle with or is it isosceles?
Only you would say an equilateral triangle, wouldn't you?
Yeah, 1.27 on all 3 of the sides. That's the spacing. So then, like for our flex solution for the card edge style, the thickness range that we recommend is up to 10 mil, which would be what, point something, 0.2.
Is that American units? 0.10? Is that 0.254 millimeters? Yeah.
I'm trying to do both here.
So that's an ungodly distance.
254 thickness
for a connector as well.
Yeah.
That's pretty darn small.
Oh, that's just for the flex thickness. That's because of how the leads come out to touch off on the flex. There's other options as well, but we call those FFs here internally. FF, because it's like a flex type solution.
Oh, I thought you were going to say something else.
No. But we've got our
cables.
own
Brilliant.
Right, and then the through holes, surface mount. There's some other stuff as well.
Yeah.
Straight through hole, right angle through hole.
Yeah.
And if there is an engineer out there. And if there's an engineer out there who wants to use a nano cable or these nano connectors, and what would you recommend? What advice would you give to them? Don't do it.
Well, you got a few options on the table. If you're depending on what level of wanting to use, right? So if you just want to use something, I know you can buy stuff really quickly off of DigiKey. That's easy. That's not going to be custom. That's going to be a commercial off-the-shelf type. Otherwise, the path or course of action is your local sales rep. You can find that on Omnetics.com. There's a contact us or type of find my rep page, and then from there, just following the channel like we talked about earlier, sales, engineering, that sort of thing. Absolutely. And in terms of using them, I mean, we've had a number of inquiries at trade shows and whatnot too, where individuals may be used to using D-subs or micro connectors, and they're moving into nanos. One thing that to be cognizant of, and this is just based on some of the questions that I receive, is making sure that you can route all your traces, because they are significantly smaller. So you might need to add a layer to your board for routing, depending on which type of connector you buy, or how you feel about doing things like via in pad or whatever your general business practice is or design preference is. So,
and it sounds like that because the pin densities can be so great on these nano connectors.
Right.
It's like
yep.
you're not just you're not dealing with your standard, like I say, D subs, whatever it is. You're talking about 1.27 millimeter pitches, and then you've got 2 rows of those.
Correct.
And you have got to try and trace them out. And if you've got like 50 or 40 connections, which I take it, what's the typical number of connections you can get, or not typical? What's the maximum you can see on these types of connectors?
90.
I think we have a 91 dual row.
Yeah, you've been working on that one.
Yeah, I think we have a 50.
Is that 91 per row?
No. It's 2 rows. So one of them would have 46 and one would have 45.
I see.
Yeah, and then the longest single one I've ever worked on is 51.
Yeah.
Which is quite funny because it wouldn't be very big because the pin pitch is so small.
That's right.
But the point is, there's so many pins in that space, you have to veer probably most of them out. And so that's where you say you need your extra layers, because in fact, is that a common issue? Because if your pin pitch is so small and you've got so many pin sort of connectors, no, not connectors, sorry, got so many pins,
right?
How do you route them out if you've got that many? Do you have to veer them all and then just go through different layers?
I mean, there's one project that I worked on. It's there's 36 different pins on that guy, and that I made that that's a 4-layer flex to be able to route all of that. And you do as many on top and bottom as you can, and then when you get to it, you put the rest in the middle 2 layers. I mean,
so it's very layer hungry.
Yeah, it's kind of like if there's a article, you could Google it. It's about routing like BGA type components, and it's like, well, once every 2 rows of ball, you're going to end up adding a layer to your board, and that's obviously dependent on what your pitch and clearances need to be, and to some extent, you could almost think of it like that. Because it's
I suppose it is. Yeah, it's very simple. It's not too dissimilar to a BGA.
Right.
Pin pitch of 0.5 millimeters, I think they are, aren't they? But the issue is that because, like with the BGA, it's the density, and you've got so many of them in a long row, and this pin here might need to go over there. This one might need to go over there. So already you've got crossing over, and so. That's when the vias come in, and then you've got to try and carefully route it.
Yeah, and I don't care how fancy your software is. At some point, the auto router's not going to get you the.
Lord!
Right.
I despise auto routers now. I used to use them all the time. I was quite lazy, and then I actually started working on some commercial projects, and I realised that when it comes to EMC, they are useless.
Yeah, they'll get you the low hanging fruit, but it's like, what good does that do me? Now the stuff that I really care about. I got 6, 8, 10 vias in a trace line to go from A to B. This isn't going to work. Yeah.
No. That's fascinating. That's absolutely fascinating. And it's kind of hard to appreciate that when you go down to that size, that all these problems that you normally wouldn't deal with connectors just suddenly come up, especially if they're surface mount, nano size. It's just absolutely mental.
Well, I mean, that's the thing too. Like, just for forming wire.
Yeah, just forming it is
spring back and all that.
Yeah, you've got spring back to deal with. You have the fact that you've got to try to reach into these small areas.
You know what? I hadn't even considered that aspect of the connector. You've got to make the bloody thing. Forget about routing it and sticking it on a PCB. How do you take a wire that small, turn it into a spring, and feed it through something?
Right.
Yeah.
That's why we have like 300 microscopes here and tweezers. Many tweezers. Absolutely.
So is that manually done?
Yes.
Yeah.
Well, that's the thing too, Robin. There's 3 of us on this video chat here. All 3 of us could have, let's say, the same 25 position connector, but we want 3 different wiring diagrams. Totally doable. So it's manual because it's just how it plays out.
Yeah.
Absolutely.
And
I invite you to stop by for a visit. There we go.
Oh, I definitely will. I definitely. If you book the flight for me, I'll come along.
Oh, but, imagine that.
But here's the question. So does that mean that so you know the generic off-the-shelf nano connectors, are they automated or are they also manually produced?
Manual.
Manual.
Correct. Yeah, we do have, I'll say this, when you come for your visit here and I give you the tour, we do have equipment that we're developing for doing some of the board mount solutions automated. And we're just starting out semi-automated, again, to prove the process because everything is so small. But yeah, it's...
I still can't believe that it's manually done.
Absolutely.
Yeah.
That is absolutely insane because I can imagine those connectors. Because
I'll walk out after this, take a picture of the floor.
Please do. Absolutely.
Projects looking towards the other end of the building, and I'll email it to you just so you can see it.
We'll get that into the podcast if that's all right with you guys. And I tell you what, if you could do me a massive favor, if you could get if you can get like a view through the microscope, that would be brilliant.
Easy.
Excellent. Definitely get that on there because that would be a treat for our viewers.
Will do.
But again, because you're saying these are pin and socket connectors, so they've got little pins, they've got little sockets, so they stick in. But you still have to feed through the contact that goes to the board, and that feeding is manually done. And so, and does that mean do you have to manually manipulate it, or is it sort of formed like that?
We build some tooling to do that.
Yeah.
So we'll build like a little fixture. You'll put the connector with some straight leads in, and then it'll bend them for you.
Bite and like fold it in or something, and then creates it. I see. But you still got to put those things in with a pair of tweezers.
You manually load it into the connector, and then you manually right now put it into some tool that we put under a manual press that you use to form the leads.
Yeah, some of the materials like that super soft copper, that mill wire, it comes in on a spool and we cut it to length based on what the connector is. It's still going to have some level of inherent curve in it, and that needs to be taken out. You can use straighteners, you can do all this other stuff, but you need to get that taken out so that way when you put it into Scott's fixture, let's say, and you go to form it, that they all bend correctly. Otherwise, you end up with all sorts of other challenges too.
Yeah.
And so what you're saying is that the storage of that wire on a spool puts in kind of, would you say it puts in a bit of a memory into the material? Correct. So it kind of like, so when you heat it, it will go back to the way it wants to bend in a certain way.
You can see the arc of like, let's say a 4-inch spool. You can kind of see it naturally has that banana type arc to it. Like you could piece them all together and make a circle.
Right. So you have to use some level of manual manipulation to get that in order to properly run through the fixtures or forming tools.
And what kind of do you have like a failure rate figure for when you're doing it manually, or is it one of those things where it's a procedure you've got completely down, sorted, so it never really has an issue?
No, I don't know. The thing about it is, for something like that, when you're early enough in the process and you can manually manipulate it, we very, very rarely have fallout, right? Because, it didn't go in the tool properly or whatever. Before you even form it, you'll see that.
You'll know.
It. So, I don't even have a number for you, but I can tell you. So it's kind of like you'll get most of them done right. It's just that it's a painful process because someone's going to sit there with a pair of bloody tweezers and doing the whole thing.
And you might have that occasionally didn't quite get in the tool right, but it doesn't damage anything. But now you got to manually finish the bend or it out. But you can save it. You just have to put a little bit of manipulation to it or some attention.
Yeah. And so that really highlights just how intensive the process is for making these connectors and the skill required, because on that kind of scale, I mean, I don't think I even could do that myself.
Yeah, it's not for everybody. I mean, just in terms of the process, last week, we were having a meeting, and the statement was there was a particular customer harness, and the process has 166 steps in it.
That's a bit excessive.
166. It's what it is. Yep. It just depends on what the customer needs.
That's excessive. That's ridiculous. What can you tell us what the application was, or at least the area of industry or the environment?
Man, I'd have to look on that specific one. I'd have to look. it's hard to say. I mean, there was one that there was a company, they do satellite type stuff that Grant had brought in here this morning to look at. That guy had, I mean, it was just a myriad of connectors. It was bananas, it was RJ45s,
Yeah.
it was micro, it was nano.
It looked like the kitchen sink.
That's what I called it. I called it the kitchen sink because it
Kitchen
had
sink.
everything on it. And
That's
it was
so
for one of our, we did it as a first run build to kind of prove out the process and everything else in here.
You should have said to the customer, would you like a circuit with your connectors?
Right, you might as well at that point. Yeah. Yeah, I did call it the kitchen sink because it was
every
everything
style
on there.
connector you can think
I
of.
did call it that. Mm-hmm. Absolutely.
Blimey, that is crazy.
Yeah.
So, so before we wrap up this podcast, is there anything you'd like to say to the viewers out there?
This is the same thing I see at trade shows. There's a number of people that may be very familiar with using the D-subs. They may be familiar with using the micros. There are some things that are different if you're transitioning down in size, as you well pointed out, Robin, right? Challenges that you may not have had to face before could be a bigger thing. You might have issues with your supplier not wanting to do lines and spaces or annular rings for through holes and that sort of thing that you're going to have to find some solutions for. But we've got experience with that. A lot of times we can help guide people to that, as we had mentioned. And the bigger thing is don't be afraid to just reach out, right? So I know we go through the sales reps and that sort of thing, and I know engineers are very particular about not wanting to put in their information and that sort of thing. But at the same point, if you've got some questions or something else that you think we can help you with, by all means, just do it. Reach out. Yeah. And I can always tell them not to bug you.
Pretty much. Fantastic. Well, thank you ever so much for taking the time to speak to us today. It was a pleasure having you on.
Yeah, it's always fun. I like it. It's always a good time, Robin.
Fantastic.
Thank you for having me.
Thank you very much.